Hi, my name is Yesu Benjamin. I'm a PhD candidate in philosophy of technology at the University of Twente, and I'm here to present my paper, Machine Learning Uncertainty as a Design Material, a Post-Phenomenological Inquiry. So I'd like to address two key takeaways from our paper up front. First, machine learning uncertainty is often explained or engineered away, but we argue that for design research, it can be understood as a key material for articulating the novel capacities of this technology. Second, as a contribution, we develop a conceptual vocabulary that seeks to give designers a foothold on machine learning uncertainty in exactly this way. So we focus on machine learning uncertainty as an underexplored material facet that is strongly related to ML as a suite of essentially probabilistic technologies. The technical fields usually distinguish between aleatoric and epistemic uncertainty, which can be understood as data noise and model variance, respectively. Yet so far, both have been predominantly treated as an obstacle to be explained or engineered away. We are interested in uncertainty as a simple part and parcel property of ML and how we can understand it as a shorthand for the particular capacities of this technology. So to understand what machine learning uncertainty could be as a design material, we analyzed 4 design research projects that involved ML through the lens of post-phenomenology. We follow the hypothesis that design is philosophy and practice, and thereby see our case studies as holding latent or unarticulated propositions about machine learning uncertainty as a design material, and this we explicate through post-phenomenological analyses. So for our analyses, we picked 4 case studies from various design research methodologies that all employed ML. And here I'll only describe 2 case studies to situate the conceptual vocabulary we developed. So please do consult the paper for more in-depth insight on analyses and implications. So as a general principle for designing with machine learning uncertainty, we propose thingly uncertainty. Rather than embodying fixed scripted readings of the world, machine learning-driven artifacts can be much looser and uncertain about the world. And as such, they act and adapt within a continuum of relations to their environment and the humans that experience them. And in the paper, we present provocative shorthands for the ways in which thingly uncertainty manifests. So the first provocative shorthand is pattern leakage, which we position as the propensity of probabilistic patterns to shape the world they are deployed to represent. So in Wang et al.'s design fiction, a support vector machine is used to classify brainwave signals, and this is used in content moderation. But because the incoming data is uncertain, the SVM may include or exclude a wider spectrum of patterns than expected, which would have knock-on effects for the kinds of things that are then shown or hidden in, for example, a social media platform that uses this for content moderation. So this probabilistic knock-on effect of uncertainty would term pattern leakage. Pattern leakage can thus be used by designers to tap into or even exaggerate how uncertain machine learning-driven artifacts can be about the patterns they recognize, and thereby design products or services that leverage this kind of loose access to the world. Equally, design fiction may use pattern leakage to expand the scope of unintended effects of technologies, where not only explicit breakdowns affect deployments, but also unobservable slippages intrinsic to the technologies used. The second provocative shorthand that we articulate is futures creep, which we use to denote how probabilistic, uncertain predictions shape human experience of temporality. So in Biggs and Desjardins' speculative design project, the researchers developed an artifact called high-weather pants for cyclists, and a microcontroller in these pants lifted or lowered the pants leg depending on if the cyclist was in an area that is predicted to be flooded in the future due to climate change. So futures creep addresses how the way we relate to the world is increasingly shaped by ML's uncertain futures. Futures creep can therefore be exploited as a way to center non-anthropocentric predictions in speculative design to develop intermediary artifacts that keep time on machine learning technologies on human scales, or to exaggerate the perceived agency of artifacts by suspending typical constraints on response patterns in interactions, for example. And lastly, we also sketch horizontal relations as a way that our shorthands feed back into our theoretical framing. And we developed this as a schema for how thingly uncertainty manifests in human technology world relations, representing how the latter are increasingly becoming embedded in ML's ways of predicting the world. So to sum it up, with our paper, we present a conceptual vocabulary for ML uncertainty as a design material. And in the future, we seek to start from these concepts for empirical work, designing artifacts from the ground up using this vocabulary, and then also expand it accordingly. So thank you very much. Do reach out to me via email or on Twitter. I'm always eager to discuss implications or applications. And thanks again. And I'm really looking forward to our discussion now. Thank you.